Okay, in this video, we're going to work on adding and subtracting fractions where the numerator and denominator are polynomials. In order to do that, I wanted to first review how you're adding and subtracting your fractions that are just numbers. So we're going to start by doing 7/12 plus 5/18. And so when you're adding fractions, the denominators need to match. So we need to get the least common multiple, also in this context called the common denominator, for 12 and 18. The way that we're going to do that here is by factoring the denominators we have. And the reason for that is because it extends best to the polynomial case that we'll do in a minute. 12 is 2 times 2 times 3. And 18 is 2 times 3 times 3. So you can see that each denominator already has a factor of 2, so that's okay. And each denominator already has a factor of 3. But the one on the right needs 2 factors of 3. The one on the left has 2 factors of 2. So in order to make the denominators match, we're not going to multiply just 12 times 18 and call that the new denominator. Instead, we're going to insert the missing factors in the numerator and denominator. In other words, the fraction on the right needs another 3. So we'll use the fundamental property of fractions to multiply the numerator and denominator by a 3. The fraction on the right needs to have 2 factors of 2. So we're going to multiply the numerator and denominator by a 2. So now the new denominator is 4 times 9, or 36. So we'll have 21 over 36. Plus 10 over 36. Now the denominators match, and so we can add the numerators, get 31, and keep the same denominator, which is 36. So our approach to this is going to be to factor the denominators of the fractions we're trying to add or subtract, and then insert whatever factors we need by multiplying the top and bottom of the fraction by the factor that's missing in order to make it so that the denominators match. And then once we've done that, we'll be able to add the fractions. So let's try that here. Here, now that there's letters, it's actually easier than the case where there were numbers because there's not as much factoring to do. So on the left, we have 15a squared b. So let me go ahead and factor the 15. 15 is 3 times 5. We'll have a squared b. And then on the right, that one is 2 times 3ab squared. So then we need to, again, look and see which factors are missing. Numbers first. They both already have a 3. But the fraction on the left is not does not have the 2 that the fraction on the right has. So we're going to multiply the top and bottom by a 2. And then the fraction on the right has 2 and a 3, but it doesn't have the 5 that the fraction on the left has. So we're going to multiply the top and bottom by a 5. Okay, so that takes care of the number parts. So now we want to take care of the letter parts. The first fraction has an a squared in it, whereas the second one is only an a. So we're going to need to insert another factor of a in that second fraction. The second fraction has a b squared in it, that is, there's 2 b's, and so we're going to need to multiply that first fraction's top and bottom also by a b. So we're going to have 4b over, and that's 6 times 5, or 30, a squared b squared. And then we'll add to that 25a over 30a squared b squared. So now the denominators match. We can add the numerators. Let me put this in alphabetical order because I like that. So we'll have 25a plus 4b. That's divided by the 30a squared b squared. Okay, and that will do it. So once again, we've multiplied the top and bottom by each fraction by whatever factor we needed to insert into the denominator. Okay, so let's try that once again. This time we have a couple of binomial denominators. The first one is x minus 2, the second one is x plus 3. So there's no factoring to be done, right? The denominators that we already have are already factored. but they're each missing a little something. So let's go ahead and put that in. The first fraction's denominator does not have the x plus 3, so we're going to multiply the top and bottom by that x plus 3. The second fraction didn't have the x minus 2, so we're going to multiply the top and bottom by x minus 2. Okay, now that we have the denominators fixed up, we can just leave that as x minus 2, x plus 3. And then up top, I'm going to distribute. So we'll have 2x plus 6 for the first fraction, and then 5x minus 10 for the second fraction. Okay, let me combine like terms here. So this will give us 7x minus 4 in the top. And down below, we'll have x minus 2 times x plus 3. All right, so then a natural question is, do I need to multiply out the denominator, as you're seeing right here? The short answer is read the directions. If it's like a paper test, it'll say whether or not to do so. If you're using a math software like My Open Math, then it should say in the directions whether or not you need to multiply it out, or it's going to accept it either way. So let me go ahead and multiply it out. That will be x squared plus x minus 6 to finish that. Okay, keep in mind as we proceed here that if this is too fast for you, you can slow down the video. If it's too slow, of course, if I talk too much, you can speed it up. Also, you can pause the video and rewind, of course, to if there was something you missed. And definitely, as we get further along and you feel more comfortable with this, you should pause the video and try some of the examples before I work them out. So maybe this will be a good one to try that with. So go ahead and pause the video for a moment, try this problem, and then restart the video and see how it comes out. All right, so let's see. For this one, we'll factor the denominator. There will be a y and an x minus y. For the second one, it's a difference of squares, x plus y, x minus y. Okay, so now for the first fraction, it already has an x minus y, but it doesn't have the x plus y that the second fraction has. Let me rewrite this, leaving a little room for all the factors we're going to have to put in. Okay, so the fraction on the left does not have the x plus y. So let's go ahead and put that in. So I'm going to multiply the top and bottom by x plus y. Okay, and then now they both have x plus y and x minus y, but the fraction on the right is missing the y, and so we'll put the y into its top and bottom. Okay, so then down below, we'll have y, x plus y, x minus y. And up top, we should have 5x, x plus y, plus 2xy. And then I'm going to take a step or two and simplify that a little. So we should have 5x squared in the top, plus 5xy, plus another 2xy, looks like. Okay, let me go ahead and multiply out this denominator. We'll have x squared y minus y cubed. Okay, and then last thing to do is to just combine like terms in the numerator, 5x squared plus 7xy. Okay, and that should do it. Okay. All right, in the next example, we have a pair of quadratic denominators. So our first step is going to be to factor those. So let's do that. You want to be careful with your factoring. Of course, you got to be careful with everything, right? But you want to be careful with your factoring because you can get the wrong answer, yeah, of course. And also, if you find that you start getting kind of outlandish answers, crazy numbers, that's often a sign that something has gone wrong. All right. So let's see. I was talking while I was doing that, so let me make sure I didn't mess it up. M squared plus m minus 2m's minus 2. That's okay. And the second one looks okay too. All right, so they look like they already have the m plus 1. And so the one on the left has an m plus 2, the one on the right does not. So let me go ahead and insert the, sorry, it's missing the m minus 1, one on the right, one on the left has. And then the one on the left needs an m plus 2. Okay, so now they both have m plus 2, m minus 2, and an m plus 1. Okay, so we'll keep that same denominator of m plus 2, m minus 2, m plus 1. We'll have 1 plus 5m squared minus 5m. Okay, and then let me rearrange the factors or the terms in the top so that it looks nicer. And then the bottom one, I guess I could multiply that out. I'll do that in 2 steps. Let me take the conjugate binomials first. That will be m squared minus 4. And then we're going to multiply that by m plus 1. Okay, and then let me go ahead and do the last of it too. We're done with the addition piece. It's just making it look good now that it's taking more time. All right, so let me do this multiplication. I need m squared minus 4 times m plus 1. Okay, I'll use the distributive property to get this done. I'm going to multiply m times m squared minus 4. And then we'll add in 1 times m squared minus 4. Okay, this will give us m cubed minus 4m plus m squared minus 4. So let me put that in order when I recopy it. We'll have m cubed plus m squared minus 4m minus 4. Okay, so this one took a little time, more time than the beginning ones, because we had to factor in the first place, and then all that multiplying and simplifying took a little time at the end. Okay, so that takes care of some examples involving addition. We're going to switch to subtraction now. Fortunately, subtraction works basically the same way, except of course that you're subtracting, not adding. But again, as before, we're going to start by factoring the denominators we have in a numerical example. So 3/4, we'll write that as 3 over 2 times 2. And then we'll subtract 5 times, this is 18, so that's 2 times 3 times 3. Okay, so as before, inserting missing factors, the fraction on the left is missing a couple of 3's, so we're going to insert that. So let's do that. So we're going to multiply the top and bottom by 3 times 3. And then the fraction on the right has a 2 and 2 3's. The one on the left has 2 2's. So we're going to need to add in a second 2. And don't forget to do that in the numerator as well as the denominator. So we will have 27 over, and that's 4 times 9 or 36. And second fraction, 10/36. Taking the difference, that will give us 17/36. Right, so as with the addition examples, and here our subtraction examples involving polynomials are going to have the same basic features, just inserting missing factors. Okay, so let's try a few examples. So here we have p over p plus 4 minus p minus 2 over p minus 5. So let me first rewrite that so I can have more room, put in the pieces I am missing. So here the fraction on the left needs a p minus 5, and the fraction on the right needed a p plus 4. Okay. So then our new denominator is p plus 4p minus 5. And then up top, we'll have, let me go ahead and multiply as I do this, p squared minus 5p minus, and then all that is being subtracted. So let me wrap that in brackets. This guy is p squared plus 2p minus 8. Then in the next step, I'm going to distribute the negative. And in the denominator, we'll go ahead and multiply that out. Okay, almost done here. This time the p squareds go away. We'll have negative 7p plus 8 in the top, and then p squared minus p minus 20 in the bottom. Okay, so hopefully you're trying some of these, and hopefully also you're getting the right answer. If there's something in here that you're not getting, or if I make a mistake, hopefully not. If I make a mistake, please let me know. Okay, so let's try this next one next. We've got 2x over x squared minus 4. That will factor as x plus 2x minus 2. And 2x. And then our second fraction was just x plus 2. So this time I don't need to make any modifications to the first fraction because it already has every factor of the second denominator. So it'll only be the second fraction that needs messing with. We'll just need to insert that factor of x minus 2 in the second fraction. Okay, so now to clean this up, we'll have 2x minus, and then in parentheses, x minus 2. And then I'll do more with that in a minute. Down below, we have x plus 2, x minus 2. Okay, up top, we'll have 2x minus an x is a single x, and then actually plus 2. So that's pretty interesting. A minute ago, I was going to multiply out the denominator, and I'm glad now that I didn't, because as you can see, we're going to be able to divide out that factor of x plus 2. And so in the end, we'll be left with 1 over x minus 2. So it looks like even if you are going to end up multiplying out the denominator, it's a good idea to wait until the end so that you can see if maybe something is going to cancel or not. Okay, so there's our subtraction example. Okay, so these are pretty fun, at least fun for me. Hopefully you're getting something out of it too. In the next one, once again, factoring. So let's do that. So, all right, so I factored the denominator of the left-hand fraction, and then in doing so, I noticed that there was a factor of x minus 6. And so on the right, when you see that 6 minus x, I thought it would be a good idea to factor a negative out of that so that that creates another factor of x minus 6. So then, in order to finish, our second fraction only needs a factor of x plus 1 inserted into the denominator. Okay, and so what do we have? We have 3x minus 1. There's a negative minus a negative, which will make it plus 2x plus 2. And then down below, we'll have x minus 6x plus 1. And so then let's clean up the numerator a bit. That will be 5x plus 1. And down below, x squared minus 5x minus 6. Okay. All right, so we are getting there. In this next problem, our subtrahend, that's the thing that we're subtracting, the 3 is just a whole number. So in order to start with this one, remember that 3 is the same as 3 over 1, right? And so on this one, we're only going to need to mess with the second number, that 3, and insert a factor of x minus 7 into it. So our 2x plus 1 over x minus 7 will stay the same. And our 3, going to multiply the top and bottom by x minus 7. Okay, now they're both whatever over x minus 7. So we have 2x plus 1 minus 3x minus 7 over x minus 7. So then distributing to remove the parentheses. And then combine like terms. So that'll be minus x plus 22 over x minus 7. That looks good to me. If you don't like that negative out front, you're perfectly welcome to change that into 22 minus x, although it's not necessary, over x minus 7. Some people don't like those stray minus signs hanging out in the front end. But either way, it's okay. That's that. Okay. This one is a little interesting. It's got 3 terms in it, and also you'll notice that there's 1 addition and 1 subtraction. But how we're going to do this or work with this is the same as we've done with all the others. We'll start by factoring the denominator that we have, or denominators we have. In this case, most of them are done for us already. And you can see that they are just v plus 1, v minus 1s for these, but the first fraction is missing a v minus 1. So, right, so now I just want to space things out a little bit. So for the first fraction, we need to insert a denominator factor of v minus 1. So let's do that. Sorry, my pen is acting. Hold on. All right, let's try that again. So we need a v minus 1 in the top and bottom of the first fraction. We'll need a plus 1 in the top and bottom of the second fraction. And the third one doesn't need anything, right? It's perfectly fine as is. All right, so now our denominators are all the same, and so we can combine the numerators. So we'll have v minus 1 plus 3v plus 1 minus a 6 all over all of these two, v plus 1, v minus 1. Okay, and then multiplying everything out, once again, we'll have v minus v plus 3v plus 3 minus 6. Down below, let's once again keep that factored in case we get lucky and something simplifies out. So we'll have v squared plus 2v minus a 3. And then down below v plus 1, v minus 1. So now that numerator looks like maybe it'll factor. We can try v plus 3, v minus 1. See if that worked out. V squared plus 2v minus 3. Yeah, sure. So we're going to have that situation again where one of the factors of the denominator and numerator cancel out. So that simplifies. So you want to try to always check and see if something is going to simplify. You don't want to get a wrong answer just because you didn't simplify out what you needed to simplify. Okay, so that takes care of that one. Okay. All right, so that basically covers everything that we need to cover in this section. So if you've had enough, of course, you can stop now. You're even still there. But if you had enough, you can stop now, or if you want, I've got 3 more examples to show you. So let's take a look at those. So as before, it's just about factoring and inserting missing factors. So let's see, we have 5b. On top, we'll have a squared b minus 2 in the bottom. And then we have 2b, b plus 2, b minus 2. And then, so the first fraction, both already have the b minus 2. But the first one is missing that b plus 2. So let's go ahead and put that in. And let's see what else. The second one is missing the a squared. So let's go ahead and put that in the top and bottom. Okay, so now the denominators match. And so let's begin multiplying out the add-ins in the numerator. We'll have 5b squared plus 10b plus 2a squared b in the top. And then down below, I'll do this in 2 steps. We'll have a squared times b squared minus 4. I'll multiply the conjugate binomials together first because it just seems easiest. Okay, 5b squared plus 10b plus 2a squared b. And then down below, we'll have a squared b squared minus 4a squared. Okay. So next step, more factoring to begin with. So we'll have x minus 7, x plus 3, it looks like. And then down below, this one is another one of these ones that's kind of 7 minus x in it. And I see that I already have an x minus 7. So maybe when I write this down, it would be a good idea to factor a negative out of that 7 minus x and call it x minus 7. Okay, so double check for yourself. That is, in fact, the same as the original problem. But we've just made it look more useful by turning it from 7 minus x into negative x minus 7. All right, so we'll see in the next step that those subtracting a negative, we can just turn that into an addition. And then we're going to need to add in a missing factor of x plus 3 in that second fraction. And once we've added in the x plus 3, we should be okay. So we'll have negative 9x minus 17. And we're going to add to that. And let me multiply out this product of binomials on the right side. We'll have x squared plus 4x plus 3. And then down below, let me wait on that. X minus 7, x plus 3. Although I don't think we'll get anything good out of it. Maybe. X squared minus 5x minus 14. I mean, we will. There's x minus 7, x plus 3. X squared minus 5x minus 14. Two numbers to multiply to negative 14 and add a negative 5 will be negative 7 and positive 2. So we will get that x minus 7, x plus 2 in the top, and then the bottom stays the same here. So now you can see that those x minus 7s are gone. And we're just left with x plus 2 over x plus 3. Okay, last one, and then we're done. So here we have single binomial factors in the first two denominators, and then the second one is degree 2. It's quadratic, and so we're going to get 2 factors from it. So we'll have c plus 5, and then we'll be putting something later. C minus 3 for the second one, and minus. Okay, down below we'll have c plus 5, c minus 3. Okay, so it looks like our common denominator is going to be c plus 5, c minus 3. So as before, we'll be inserting those missing factors in the first 2 fractions. And the third fraction doesn't need anything. Okay, so we're okay. So we will have 2c squared minus 6c, the first one. We'll have 3c plus 15 in the second one. And then minus 13c, be really careful here, negative 13c minus 15. Both terms in that numerator are getting subtracted, okay? So make sure that you don't have a plus 15 there in the back. All right, so then c plus 5, c minus 3. And then we should have 2c squared. And then all kinds of stuff. 2c squared, we will have how many c's? Negative 3 minus 16. That's, sorry, negative 3 minus 13 is negative 16. Minus 16c. and then that's it. Okay. C plus 5, C minus 3. Okay, so then doesn't look like we get anything good out of simplifying that numerator. So we'll leave the numerator as is and go ahead and multiply out the denominator. Okay, so that should do it. That's the end of this section on adding fractions and subtracting fractions with polynomial numerators and denominators. Let me know if you have any questions on that, and then have a great day.